Hey everybody, it's Miss Peachy from your physics class. So today what I'm doing is a little mini lesson on some of the stuff from your first unit. We don't have any virtual classes until September 14th, the week of. So I want to make sure that I'm filling in the gaps a little bit here with some stuff that hopefully you'll find useful. So I'm actually using some new tools here today. I have a new tablet that I'm going to try to use to write with. It's not super great, so apologize if my writing's pretty bad on the board. I'm also using kind of this new notebook tool just to see how everything works. All right, so let's go ahead and get started. So today we are going to be looking at primarily velocity. We're going to be looking at the difference between displacement and distance, velocity and speed, what average speed is and average velocity, and instantaneous velocity, and how all of this looks on a graph. So it's a fairly simple part of what you're doing so far. So hopefully it won't take too long. So first of all, let's look at the difference between a vector and a scalar. I think that kind of gives us a good place to start. So a vector is what we're going to be using quite a bit of. There we go. I lost my little cursor for a second. My penmanship isn't the greatest on this board, so I apologize. So vector, and the other thing we have is scalar. Okay. So vectors have both quantity and direction. Whereas scalars only have the quantity. So in today's lesson, kind of the differences here is a vector is something like velocity. Velocity is a vector. Not only do you know how fast something's going in that particular case, but you should know in which direction they're traveling. It's very important when you're looking at, any kind of motion, when you're trying to figure out a problem, that you know which direction your object is that you're tracking is traveling. A scalar doesn't have that. So a comparable scalar to velocity is speed. Another thing we're looking at today with vectors is displacement. Displacement's a vector, but distance is scalar. So let's look at how those two kind of relate to each other, shall we? With displacement versus distance, right? Let me put on the board just put a full coordinate system up here for you. All right. So let's say you start here and you start walking to the north. We'll call this north. We'll just use graphic coordinates here. All right, you start walking to the north. Let's say you walk to the north 1, 2, 3 kilometers. So you go 3 kilometers to the north. And then you turn and you head to the east. And you start walking 1, 2, 3 kilometers to the east. So you end up here. And then finally, you walk to the south. Oops. And you walk 1, 2, 3 kilometers to the south, right? So your final spot, your final position is right here. Now, according to looking at distance, you can say the total distance you traveled is 3 kilometers north plus 3 kilometers east plus 3 kilometers south is 9 kilometers, right? However, your net displacement looks at your beginning position and your ending position and the difference between them. So you end up with a net displacement of 3 kilometers to the east. As you can see, these are not the same kind of measurements we're looking at here. It's not just as simple as saying I walked 9 kilometers and my final direction is to the east. When you look at displacement, you look at a vector, you look at the starting point, the ending point, and you kind of look at the difference between the two of them. How I would write this is your displacement is equal to where you end up minus where you began. Okay, and then you also give the direction of that. Now you might be wondering, what the heck did I just write here? Little subscripts with an F and an I, and I'm going to explain those in just a second to you. Okay. So that's one vector, displacement. Another vector is velocity. Remember the differences here? We have speed, which is scalar, and you have velocity, which is a vector. So speed is how far you went in what period of time. We could use a previous problem to calculate average speed. You went 9 kilometers, say it took you, trying to think of how fast you'd be walking here. Say 3 kilometers per hour. So it took you like 3 hours to make that journey, right? So on that previous page, if you had 9 kilometers and it took 3 hours to make it, that gives you a rate of 3 kilometers per hour. That is your average speed. Okay, so velocity, when you look at average velocity is a little bit different. You're going to So average velocity is calculated kind of the same way we did on the previous screen with displacement. So with average velocity, you're going to take, and I'm going to write this a little differently so you can kind of look at some of the ways in which stuff is notated in physics. First of all, I'm going to write V for velocity, but I'm going to put like a little subscript AVG, so you know that that means the average velocity, okay? And then I'm going to do X sub F minus X sub I over T sub F minus T sub I. So we got some kind of weird denotations here that you may not be familiar with. So let's look at those. Our subscripts indicate kind of a specific subgroup of that measurement. So we're looking not just for velocity, we're looking for average velocity. The other ones we have are letters. F represents final. And I represents initial. So you'll see these denotations to help you kind of key in on which data points you're actually looking at. This is our final position minus our initial position divided by our final time minus our initial time. Sometimes you don't see those particular denotations. Sometimes you'll see something that uses numbers instead. Like I've seen it drawn, written, and sometimes I do this. I'll have x sub 2 minus x sub 1 divided by t sub 2 minus t sub 1. Essentially, this is the same thing, okay? The second x position minus the first x position divided by the second time minus the first time. If you really are looking at the beginning and ending points, this is going to be the most correct over here, right? This is going to be most correct. Oh, I hit the wrong button on my... I gotta select the draw, but for some reason something happened with my thing. Hang on one sec. I got it. Oh no. Hang on, guys. Sorry, 1 second. Okay, my bad. I'm trying to use this little pen and I don't know what I did, but I screwed up. So this is probably most correct here, right? But either one's fine. Either one works just as fine. Okay. So let me go ahead and just, I'm going to erase this part. And we'll just use that first part. Okay. So in this case, our final position was the 3 kilometers to the east, right? Minus 0 kilometers, which was our initial position, divided by the total amount of time, 3 hours. So we'll come up with a final average velocity here of 1 kilometer per hour. Okay, so differences in how you calculate those based on what you're actually looking for. They're different concepts, really. Now, the other thing you're going to see here is you're actually going to see a graphical representation of all of this. So you can, let's do another graph here. You'll see a graph we call a position versus time or displacement versus time graph. And on a displacement versus time graph, displacement is on the y-axis and time is on the x-axis. Okay? And when you do the displacement versus time graph, you're actually graphing the item's position in the universe at that particular interval, right? So here is where you begin at your point of origin. So in this case, you can say, let's say you're traveling this actually is a good representation of straight line distances. So we're traveling away from the origin. And we go, let's say, 3 kilometers. 1, 2, 3. Again. 1, 2, 3. And it took us an hour to make that trip. So I would have a data point right here. 3 kilometers in 1 hour. And then let's say I stop for a second. So for another, let's do 1 hour here, 2, 3. So for about a half an hour, I'm just sitting there taking, it's lunchtime. So I continue that. And then, so I'm going to connect these lines. It's going to be messy. I'm a little bit worried because I'm not very good at, I'm going to try to use my, there we go. A little bit better, right? There. And then at that point, I'm like, you know what? I'll just keep walking. At this time, I'm going to go in 1 hour. I'm going to go another 2 kilometers. I'm going to slow down because I'm a little full from eating. So I'll continue to mark my. So I have another hour. So we're about 2.5 hours, right? We're going to go right about there. So we're going to connect those. See, this is what happens when I try to draw without the line tool. I'll try the line tool. Okay. Well, come on. You got this. You got this. Right there. Right? And just sit there. There we go. Beautiful. All right. So what I want you to notice is in this case that the beginning portion of my journey, my line is actually steeper. The slope of my line is steeper than the ending part of my journey, right? But I'm still getting further and further away from home. Now, this is what we call one-dimensional motion. It's not like earlier where I was going to the north and then to the south and then to the east. We're only able to graphically represent this motion if you're traveling in a single plane. So straight, it's like walking on a number line. You're going straight away and straight back. So in this particular case, you're not going and changing directions from north to south, to east to west, and stuff like that. So now here we are at hour 2.5, and I decide, you know what, I'm how many kilometers? 1, 2, 3, 4, 5 kilometers away. I want to go back home. And I just realized I got an appointment. I got to get to work, man. And I'm going to get in trouble if I don't get to work. So I better boogie. So I run back home. So I run back home and I get there exactly 3 hours after my journey started. Oh, sorry, guys. Didn't quite connect up. I'm mad. Stay. I just held it there a second ago and it stayed. I don't know if it's going to do that for me. There. I don't know. I can't get this guy to kind of. It's a little wonky. My bad. So what you're going to notice is a couple of different things. You have a positive slope in 2 different segments, right? Here you have positive slope here. You have positive slope here. So those are positive velocities because I am in both cases traveling away from my starting point. When I travel back towards my starting point, this is a negative velocity because the slope is negative. So positive and negative velocity does not mean like speeding up or slowing down or anything like that. It has nothing to do with changing speed. It has to do with whether or not I'm moving, away from or toward my starting point. It's got to do with the directionality, not the actual quantity. Does that make sense? And here, there's no speed at all. I'm sitting there eating my lunch. So my line is completely horizontal. So in that case, we have no speed. Okay, so velocity is 0 there. So kind of keep those things in mind when you're looking at these distance or displacement, or position versus time graphs. This is kind of what you're going to see on these. A couple of different things on here that you can find. First of all, you can find something called instantaneous velocity using a displacement versus time graph. Instantaneous velocity is how fast am I going at any particular interval along my journey. So if I want to know how fast I'm going right here, for example, then I'm just going to look at the slope of this line right there. So just the slope of that line. Or if I want to know how fast I'm going here, I look at the slope of that line. These are nice straight lines with a continuous slope all along them, right? Thing is that sometimes you don't see that. Sometimes you actually have a curve. And when you have a curve, let's say I have something like that. And that's my speed versus, actually, you know what? I'm gonna redo that one because it just looks like I'm getting faster and faster and faster and faster infinitely, and that's kind of dumb. Let's say it looks more like that. I like that better. Because it's like I start going really fast and then I kind of peter off and maintain a constant pace for a while, and then I'm starting to slow down because I'm getting tired, right? So that's more like what it might look like in reality. So in this case, if I want to know how fast I'm going at any specific interval, I then need to know the slope of that particular point. So I pick a point on the, oops, let's do that again. I pick a point that I want to know how fast am I going right here. And then I take and I draw a line that's tangent to that point. And this might be a little bit of a challenge for me with my drawing tools, but there's my tangential line. I don't know how, sorry guys. It's like, when does it decide to just become a line? Did I just hold it? I'm trying. Oh, I had it. Hang on. Okay, you dummy. Sorry. There, I think I gotta click it. I have this little button. I gotta click and it just trying to. So it's not beautiful right now. I'm gonna move it. Just if I can click and move it. Can I click you and move you? No, I can't. Oh, let's just pretend it's actually tangent, even though it's a little bit wonky. So the point is that then I take this line that I drew tangent. How do I get you back? How do I get you back? No. No. Okay. There we go. Uh-oh. Okay. Then when I do this, I actually am going to... I'm struggling, ladies and gents. What's going on here? For real? Okay. There we go. I then create... Sorry. Really bad lines. Whatever. This is why I just like using my regular pen and paper instead of this silly business. Forget it. Forget you. Let's just try to draw a straight line. I can't do it. I can't. Let's try this again. Sorry. I'm failing at drawing a straight line. Okay, sorry. Try one time. There. Good enough. Good enough. We're going to go with it, right? And we have to find the slope of this. You take y over x, right? Rise over run. And then this is your instantaneous velocity. Okay, makes sense? So if we want to find one point along that curve, we want to know the velocity of it, we then have to draw a line tangential to the curve going through that point and take the slope, instantaneous velocity. All right, going back. If we want to find average velocity, it's the same way we did it before, right? Average velocity, you take your final position minus your initial position over the final time minus the initial time, right? Same as we started off with. So that's how you do average velocity. All right. So that's kind of a good introduction to velocity, how to do, like, look at those position versus time graphs. Remember displacement versus time. In the next video segment, we're going to be looking at acceleration, and then you'll be looking at like a velocity versus time graph instead of a position versus time graph. So that'll be my next video segment. So hopefully that's enough to get you through your first couple of lessons. And if you have any questions, feel free to let me know. I hope everybody has a great day. Take care.